here are incomplete references for part 3. So we discussed the fluctuation theorem, and these are the original papers that we discussed before. And we discussed the fluctuation theorem for stochastic processes. And actually, we have seen these papers already. But this paper by Jorge Kirchen in 1998 is the first paper that pointed out that the fluctuation theorem is valid in stochastic processes. So this is a very important paper. And so after this, they realized the modern proof based on the path description. Okay, and actually Jorge Kirchen is also the first person to realize that the fluctuation theorem and the Jarzynski equality can be formulated in quantum system. Okay, so he's making important contribution in this field too. And when we discussed the Jarzynski equality for Markov jump process, we discussed the pathwise definition of heat and work in stochastic processes. And this kind of definition for stochastic differential equation, actually, we do not discuss this very much. We briefly discussed this in part 5. But anyway, in the context of stochastic differential equation, this kind of definition was done by Ken Sekimoto in 1996 or something. And of course, Chris Jarzynski, when proving his equality for Markov jump processes, he of course he made this pathwise definition for heat and work. Okay, and he defined this and he proves Jarzynski equality. He did everything here. But anyway, as for this definition, if you compare the dates in the archive post, and you find that Ken is slightly before Chris. But anyway, I'm sure that Chris didn't know about this, Ken, and this is one of many accidental coincidences we see in the history of science. And no pumping theorem, this is the original paper, and this is the paper in which the proof we discussed was presented. And there are several more papers, but if you look at this, you will at least find references in between them. Okay, so this is the end of part 3. See you in part 4.